For those of you listening at home, hey Michael, hey Julia, we miss you. We are going through the practice exam, part 1. I did print off an answer key. Now there are a couple of answers that did not print, so I'm going to have to give those to you by hand. I'd argue with the computer, but the computer is dead, so I guess it paid the ultimate price for its offense.
Your computer is still dead?
Oh yeah, it's permanently dead.
Oh, really?
Yeah, the old hard drive is totally dead, and the new hard drive, it doesn't like. Yeah, long story, but yeah. Sure. So, a couple things. Turn please on the answer key to number 5. This is the first one that the answer key, gentlemen. Jack, time to unplug. I swear, sometimes computers stop talking, it's like dragging a bull by the horn. Number 5, please write down the following. This one did not print, so please fill it in. Number 5. Wow, that's a horrible one. Let's see the one that actually works. X belongs to square bracket, -2, -1. Square bracket, and the other one is X belongs to round bracket 0, 1/9 square bracket. That's the answer for number 5. 6, 7, oh yes, number 7, the shading did not print. The bottom left-hand corner should be shaded in number 7. That's not much of a surprise, the corner read problem. But everything in that lower left corner, that sort of this lopsided diamond shape, that should be shaded. 8, 9 printed, that's fine. 10 and 11 did not print, so they're as follows. Number 10 should have 4x squared plus 14x plus 8. And number 11, I'll accept 2 different answers. X squared plus 5x plus 2 all over 5. Or if you divided each one out, 1/5 x squared plus x plus 2 over 5. Let's see if there's anything else that got missed. Yes, there was one that got missed, number 17. The eccentricity is equal to 1. And number 20, yeah, they did miss a few things. Number 20, they have the graph, but they forgot the center and the asymptotes. 20, the center is at -1, -3. There's a vertical asymptote at x equals -1. And a horizontal asymptote at y equals -3. So those are all the missing solutions. Go ahead and write those in. Let me grab my markers. And so this hour is for you to ask any questions about any of those problems. I'm going to take a wild guess and say that people would like to see number 5. Subject. Yes. Now, I don't know if you missed this or not, but you're going to need to fill in those answers. Okay. All right. Questions? I'll leave it up to you. I'm going to close the door to keep the coolness in. I mean the physical coolness. Okay. Your psychological coolness could radiate to the rest of the school. So, questions? Yeah. Number 5. Okay. This one is probably the most time-intensive problem on the test. There are 4 things you'll need to know how to do. 1, you'll need to know how to factor and solve problems that are, oh, I'm sorry. So we need to get this. Okay, good. I feel like, oh no. I have them still, so if you need them. Number 5, I'm about to give you the technique to get it anyway. We have 9 x to the 5th minus 37 x to the 4th minus, I'll finish my sentence in just a second. 77x cubed plus 153 x squared plus 164x minus 20 all over x cubed minus 7x squared plus 10x. And I want that solved for less than or equal to 0. So the first thing you need to know how to do is to factor and solve polynomials that are big, like degree 4, degree 5, degree 6, that don't factor like normal. In other words, if this factored by grouping, that would be great. It does not. I tried. So there is a technique for solving that. That's first. 2, you have to remember your basic methods of factoring, like the bottom. Third, you have to remember plus minus notation, which is how to solve this thing for less than or equal to 0. So breakpoints, roots, vertical asymptotes, poles. And then the fourth thing is to graph it on a number line and find a solution for units. So let's get the hardest thing out of the way first, that top beast. Can somebody list me the possible rational roots of the top? It's called the rational root theorem. How do you get it? Yeah.
Like take the last term,
Yep.
move it over the, like the multiples of that.
Not the multiples, but the factors.
Yeah,
Good.
sorry, excuse me.
Factors of the last
And then
coefficient.
over the factors of the first coefficient.
Factors of the first coefficient.
And
You'll get a
plus or
bunch of
minus.
fractions. Go ahead.
And then the plus or minus ones.
Correct. Plus or minus, and list them off for me. What are the factors of 20?
1, 2, 4, 5, and 20.
Right. And you can list them in whatever order you want. I list them in pairs just so I don't miss any. 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. And then the bottom, the factors of the first, the only ones that work are plus or minus 1 and 9 and 3. You can list 3 twice if you want, but it doesn't hurt anything.
Say that like the first one was like 10, then some like fractions reduce. So like 20 over 10 would be 2.
Yes.
And 2 would be a factor of both.
Correct.
That means more likely to be 2.
It does not. It just means that you can eliminate that as as a duplicate.
Okay.
Right. Alrighty. Yeah, that would be so nice if it were. That,
So I always do
I'll have to look into that. I would know. Because I'm not 100% sure that's wrong. I mean, I don't think that's true, but okay, now. After I resurrect my new computer, I'll see if I can get there. But for now, do you see there are lots of possibilities? 1 over 1, 20 over 1, 2 over 1. So basically the number 1 and negative 1, 20 and negative 20. By the way, what's the range of possible roots from what to what? What's the smallest possible guess, the biggest possible guess? Yeah. From 20 to negative 20. You look at this and you take the first in line, plus or minus. Yeah. So anything bigger than 20 or anything less than negative 20, don't bother guessing, because it won't work. At this point, it's guessing time. Now do an intelligent guess. Start with easy ones and start with numbers that are actually on the list. I would not guess 7. I would not guess 3. I would not guess 1/2, because there are no fractions that equal that. What would you try first? 1. Yeah, 1 is a good logical thing to do. Does anybody remember the quick way to test? Yeah, synthetic division. Talk me through it. So let's say you want to try 1. Let's put it in the box.
Don't you just list the numbers in front of you?
Yeah, coefficients. So 9,
Negative
Negative 7.
7, negative 7,
okay,
153, 164,
and negative 20. Yeah, 1 is a logical place to start. By the way, if it doesn't work, don't beat yourself up. Just go to the next number. How do you do this? Sophie, help me out here. How do you run synthetic division? What do you do first? Add. So So 9 plus nothing is 9, then what? Yeah, then you multiply. So you add, multiply, add, multiply. So okay, 9 times 1 is 9. Go ahead and add. So we're good. It's negative something. Well, think of it as like adding 10 and then throwing one back. Yeah, there you go. And now multiply. Keep going. Add. Fine. Correct. Take over to the each one. What do you do next? Times by 1. So 105. Go ahead and add. Second. Oh, yeah. Thank you. Go back. And down to 48. Good. Multiply. Add. Second. 212. Correct. Multiply. Keep going. 190. Correct. No, actually no. 190. Yeah, 192. Good. Did that work? No. Why not? How do you know? It's not 0. So, what would you want to try next? Definitely, negative 1. Start over with the original numbers. 9, negative 37, negative 77, 153, 164, negative 20. Go for it. Take the first 3. 9. Okay. 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 Negative 31, correct. You can keep going if you want. Okay. Yep. Okay. Ding, 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 ding. So what? That's actually where we first started saying that. So x is equal to negative 1 is a root. Which means up on top, we can put 1 parentheses. Somebody tell me what it is. So actually I would add that to the root. So number of roots, vertical asymptotes, and then holes. For now, let's just call this x equals negative 1. What parentheses did that come from? X what? X plus 1, exactly. Steve, take over.
So then you take the bottom part and add negative 46, right?
Second? What?
Then would you take the bottom part and then you would synthetically substitute that?
Something from there, correct. You do not have to start over. So let's say you're starting from here. Does that factor of any normal method? This is actually the 4th.
No.
No, it does not. Not that anything has to. So it's guessing time again. Negative 2. Okay. I will also give you a hint. Do you notice the first number? Chances are, when you're talking about things that are likely, chances are that first number is going to be in the denominator in one of the roots. Chances are something over 9 is going to work. Just saying. But you want
probably get that answer more easily in factoring later on though. Because guessing like something over 9.
could be.
And
There are,
try
and
and solve
that's
it.
true. There are a lot of things over 9. 1 over 9, 20 over 9, 2 over 9, 10 over 9, 4 over 9, 5 over 9. That's horrible. And then there's a negative
Blocking
version.
it is annoying.
Right. So, we could try it. I don't know, you wanna do what?
-2.
-2? Tell you what, Pete, do me a favor, run -2 for me.
Alright, so first you would get 9,
Okay?
then you get -18,
Okay,
then you get -64,
correct.
then you would get 128,
128,
then you would get 97,
yes.
then you would get
Negative something.
negative 1, 1,
I do 90 times 2 and 7 times 2, if that helps. 194.
You would get -10.
Yes.
You get 20 and you get 0.
And glory be to God, we have another root. So x equals -2. Looks like it's another root. And what parentheses does that come from, Pete? X plus 2, correct. Looking good. Noah, take over.
So we'll choose another one.
Right.
And I don't think that factors, so we can just go ahead and.
Okay.
We can try a regular one,
So, like what?
like one.
1? We already did.
So one, don't you think that we do that?
If it doesn't work once, it won't work ever.
Really?
Correct.
I did one for one. Yes, you're wrong.
Okay, yeah. If it doesn't work the first time, it won't. Now, by the way, if it does work, it might work again.
Oh.
But if it doesn't work the first time, it never will.
Oh, okay. And then we'll do
Any other candidates?
1/9.
Want to do 1/9?
Yeah.
Okay. Let's try it. Can anybody see this up here? Okay, sorry, I'm crawling on the ground. 1/9. Now, one other helpful hint on this is there's good news and bad news for guessing fractions. The bad news is there are a lot of them, and there are at least 12. Like, yeah, 1/9, 20. Pretty much all these over 9, and then all their negatives. But the good thing is, are you listening? If you try a fraction, look up here where I'm pointing. Everybody, including people in the background. If you try a fraction and you try running, if any of these turn out to be a fraction, stop. It's not working. Okay? They have to be all whole numbers at the bottom, otherwise it fails. So Noah, go ahead.
0 plus 9 is 9.
9,
And then I 1/9 is 1.
1,
Which is -63.
negative 63,
I 1/9, which should just be 7, or -7.
negative 7, okay,
And then that's 90,
90,
and that should be 10,
10,
and then 0.
and looky looky. Nice. So we've got x equals 1/9 as one of its roots. Now, by the way, some of these might not be actual roots. They might be holes. We'll find out in a minute. What parentheses does that come from?
9x minus 1.
Maybe. Just if you just this and you didn't know the coefficient.
Oh, x minus 1/9.
Right. X minus 1/9. And you're absolutely right. The height multiplier will need to go in the front. And if you want to distribute it later and make 9x minus 1, that's fine. All right. Next on the docket, Sophie. Right now it's 9x squared, just with x cubed. What would you recommend? There are several options open to you now. You can factor this. What makes you think so? Yeah, first of all, if this is squared, it's small enough that you can do, there are at least 3 ways you can solve this. One way is you can keep guessing. There's nothing wrong with that, it just takes a long time. But if something is a squared, anybody remember the nickname for that? an equation where the highest degree is 2, but the degree is 2. What's that called? Oh, math people. We did an entire chapter on this. Starts with a Q. Quadratic, correct. This is a quadratic, which means you could solve it with what? The quadratic formula, correct. You could just slam that in the quadratic formula and it will solve. Set it equals 0. But I'm going to write it up here. This is, I'll write it up here. 9x squared minus 63x plus 90. Does anybody notice anything about those three terms? Jack. Yeah, they all have 9 in common. Guess what you can do? Go. GCF. By the way, if you're solving, set it equal to 0. Pull out the GCF of 9. What's left behind if you do that?
X squared minus 7x.
Yeah, does that factor?
Yes.
Yeah, what method?
Unfolded.
Unfoil. What two numbers add up to -7 and multiply to be positive 10? Gentlemen, I want you to focus here, please.
5 and 2.
5 and 2, positive or negative? Yeah, x minus 5. And what? Good. Good. Solve these for me. You can probably do it in your head. 5. X equals 2. You just found your last two solutions. X equals 5. X equals 2. Okay. So, Pete, take over. The bottom is that factor. Oh, sorry, I should have said, what parentheses did the x equals 5 come from? X minus 5, and one more. Where does the x equals 2 come from? Good. And by the way, this will prove it. That they actually did come from there. We solved it from there. So, the bottom uses a factor. Go for it.
Well, could you try synthetic substitution?
You could, although this is a much easier way. That's a last resort. Like if you can't factor in any way, shape, or form. Notice something?
Can you try magic pair maybe?
Magic pair works with squares.
Squares.
Hold that thought. Do the system. There's a GCF of what? X. There's a GCF of x. So x, parentheses what? Good. Does that factor? Yes, into what? That should look familiar. That's identical to what was happening up here. X minus 5, x minus 2. So the bottom breaks into x minus 5, x minus 2. So, Noah, take over. So this is going to be less than or equal to 0. Are there any vertical asymptotes?
X minus 5, so they cancel. Well, so
What does that create?
a whole.
That creates a hole. A hole where? I'm going to scratch off the 5 because I thought it was a root. Go ahead.
X equals 5.
Correct.
Because everything on the bottom is vertical asymptote. So then if you look at the X, it's like X minus 2, X minus 2, and it cancels.
Right. It would have been an asymptote, but if it cancels, it makes a hole. So anything else cancel?
And then the X minus 2 is
X minus 2, so that makes a, cancel that out, and it's what?
a whole at X equals 2.
A hole at x equals 2. And Jack, take over. Vertical asymptotes. Any genuine vertical asymptotes?
I honestly cannot remember how you determine something vertical asymptote.
Vertical asymptote is if you divide by 0 and it doesn't cancel. A hole is if you divide by 0 and it does cancel. In other words, the roots are on top, the vertical asymptotes are on the bottom.
Well, x equals 0.
Yes,
That's
there you go.
vertical
There is a vertical asymptote at x equals 0. And that's the only one. The other two canceled out and make holes.
asymptote. Yeah, okay, that's right. They're just everything else on the bottom, basically.
Correct. Now, just ignore these, they're not actual roots. We thought they were for a second. Can anybody tell me, now, the hard work is done. Can anybody tell me how to finish this problem? John, help me out. How do you solve blah 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 is less than or equal to 0? What technique do you need? Plus minus notation. How do you do that?
We start with, like a graph line.
Yeah, what kind of line? What kind of, that was stupid. What kind of graph? Like a big
Like a number line.
number line, correct. Okay, yes, I did. So list all of those in order.
-2,
Yeah,
-1,
okay,
0,
0,
1, 9,
1, 9, I'm not drawing these to scale.
2,
That's why the spacing is so bad here. And then 2, and then 5. Obviously, my spacing is horrible here, but I'm just trying to make it easy. What sort of object is a -2? Root. How about -1? Also root. 0? Vertical asymptote. 1, 9? Root. 2? Whole. 5? Whole. So divide these up into regions. There'll be 1, 2, 3, 4, 5, 6, 7 regions. How do you solve this thing? Sophie, take over. These regions, I'll give you a hint, they're either positive or negative. How are you supposed to find out? Correct. If you look up here, and by the way, you don't have to count the holes. It's basically 9 parentheses x plus 1, parentheses x plus 2, parentheses x minus 1, 9, over x. And it's supposed to be less than or equal to 0. But if you look at this thingy, you can plug things in there. You just need to choose an x that's relatively easy. Yeah. 1. I would love to choose 0, but they already used it. So 1 would be good. Let me see the 1 is going to be in this region. It's not going to be in here, so be careful. It's not between 0 and 1, 9. X equals 1. Tell me the sign values of this then, positive, negatives of these things. Polly. Just one by one. 9 is positive by definition. So something, something, something over something. So what is this going to be? Positive, because it's 1 plus 1. How about his? Positive. 1 minus 1, 9. Still positive, correct. And how about the bottom? Positive. So what's the final result? Yes. This region is positive. Does that make sense? By the way, there's absolutely nothing wrong with plugging it into the extra ones. It just won't change your answer. Those actually cancel out. It'll be negative over negative, negative over negative, cancel, cancel. So how do you find the other regions? You can just test them one at a time. That's the long way. Is there another way? Here's a hint. This is what's called a single root. It changes sign over a single root. So that's minus. This is what we call a single vertical asymptote. Pete, does it change over a single vertical asymptote? Yes, it does. How about over a single root? Yes. What am I doing? How about over a single root? Yeah. See what I did? Any single root or vertical asymptote, switch. What about a double root? Oh. It doesn't change. It changes twice so fast that it looks like it doesn't change. What about a triple root? It does. Quadruple? No. So you remember that? How about a whole? Does it change over a whole? No, it does not.
Unless I forget the exception.
Okay, the exception, and I'll tell you right now, the exception is not going to be on the exam. That's when you have a war. Like if you have a, like something to the, like the 5th power, where one of these cancels, and there's a hole there, but there's a root at the same time. So a war between the root and the hole. That's the only time you might possibly get one of those. But, what about here, positive or negative? Positive. And what about here? Exactly. What regions are we looking for to solve this problem?
Negative regions.
Negative regions. list me. Let's call this region A, B, C, D, E, F, G. Which regions are good for us? No.
So that's, you want the stuff that's less than 0?
Correct.
So the negative.
Yes. Welcome back. But yes.
So
So which regions do we want for our fund? B and D, and that's it. I need those in interval notation. They want all the results that are less than or equal to 0. So, Jack, finish this off.
It's gonna be X belongs to
Okay.
square bracket.
Why square bracket? Yes.
With root.
There's a root. Do I want the root?
Yeah.
Yeah. It's safe. Does this thing want the roots? Does it want the ends? Yeah.
If
If it was just plain old less than?
Then it's all. round.
Yeah, I mean, exactly. If it's just less than, the roots are safe, but it doesn't want them. Okay, so what's, I'm sorry, -2 comma,
-2, -1, square bracket.
square bracket, and then the other one
X
is,
belongs to round bracket 0 and square bracket 1.
why was 0 round bracket?
So vertical.
It's a vertical asymptote, it's not safe to land on. That is your solution. Okay, you can do that. You can do anything I throw you in this test. And by the way, on the actual test, this is going to be much, much, much smaller. I might not even have you guess a check. We'll see. Maybe one. We'll see. All right, the rest of the hour, you can ask me about, is everybody okay on page 1, 1, 2, 3, and 4? Yeah, so number 2, okay. It says x is less than -4. That means literally you go to the left of -4. Whenever you have x is equal to 4, on a number line you just put a dot. But on a graph, it's an entire vertical line. So if I did x is less than or equal to 4, it's a solid line, but I shade to the left. Because x to the left of 4 is less than 4.
We go over 1 and 4, I guess both of them have 2 variables, and then just wondering,
Right. Is everybody okay at number 2 and number 4? Feel a little better on those? Okay, number 1. That is in standard form. It's 1x plus 1y is greater than 4. So I would do Chubby hand method on that. What kind of a border is it going to have? Solid or dotted? And why? Okay. You can go ahead and look at it.
it's not equal to,
Correct. It's not equal to. So is that solid or dotted?
it's dotted.
Dotted, because it's a bunch of open dots, right? Number 3 is slope-intercept form. So the y-intercept is 1, and then you rise 2, run 3 if you get to the next point. And those should be solid dots, because they have equal. How do you find out which way to shape those things, though? Number 1 and number 3. There's only one guaranteed way to find out which way to shape. Who remembers? Who's going to remember? Wow. Go ahead. Plug in a test a point. Plug in a point that's not on the line. And if it comes up true, what do you do? Shade toward it. If it comes up false, shade away from it. Okay? Like on number 1, I tested 0, 0, and it came up false. 0 plus 0 is not greater than 4. On number 3, I tested 0, 0. 0 is not bigger than 0 plus 1. Does that kind of make sense? All right. Civic and first page. Okay, we just took care of the top of the second page. How y'all on the corn and wheat problems? Need to talk through that? Anybody need help with that? Again, there are physical limits, logical limits, and the objective function. The physical limits are what you're physically doing. In this case, planting and harvesting. You need to choose a variable for the amount of corn, choose a variable for the amount of wheat. Like X is the number of tons of corn, Y is the number of tons of wheat. And the planting formula is based on the numbers they give you. Like you notice corn takes 3 hours per ton to plant, and wheat takes 2 hours per ton to plant. So it would be 3x plus 2y. And then there's a limit on how much planting you can do. You can't go over 180 hours. So 3x plus 2y less than or equal to 180. And they do the same thing with the harvesting. The logical limits are almost always the same. Is there anything where you just eliminate what's impossible? X cannot be negative, Y cannot be negative. So you say X is greater than or equal to 0, Y is greater than or equal to 0. And the profit is your objective. That's what you're trying to do. So your objective function is 100x plus 90y. That's measured in dollars. Number 7, graph those, shade them. And it should be, again, shaded in the lower left-hand corner. That didn't print on the answer key. So lower left-hand corner, that should be shaded. And all 4 corners of the shaded region are the corners where you're going to test. The 0, 0 is easy to see. The 0, 40 is halfway decent to see. And the 60, 0 is easy to see. How do you get 50, 15? Yeah.
Put the two together.
Right. Yeah, substitution or elimination. Take the planting equation and the harvesting equation and see where they cross. And you can do substitution, elimination, Kramer's rule, whichever you want. In other words, you do 2 equations, like 3x plus 2y equals 180, 2x plus 4y equals 160. Find out where they cross. So solve, and you should get x is 50 and y is 15. There's your mystery point. So, say again, I'm sorry? Number 12. Let me see. That is, I'll find the inverse of the function. Let me show you. Oh, and by the way, the part 2 of the exam is going to be quite a bit shorter than this part. So I did want to, let me see. I did want to give you an opportunity to revisit, and I really don't care. I'm happy to do either. But if we run out of time today, I'll be happy to finish all of part 1 on Friday during the overall day. Did anybody want to move the overall day to tomorrow so that it's more fresh in the mind? You can go ahead and think about that. You don't have to, because I'll be happy to do it on Friday or today or whichever. But just in case we run out of time, I want to make sure it doesn't fall off the mental radar. Number 12, h of x is equal to negative 3x plus 6 over 4. The very first thing I would do, h of x is just another name for what? Y. Yeah, f of x, g of x, h of x. That's a function, it's just another name for y. How do you get the inverse function? Or the inverse rather. Yeah. You switch the x and y. You trade places. It's x equals negative 3y plus 6 over 4. And then get y by itself. Go for it. Jack, on the other. Solve.
So you can multiply 4 by the side.
Okay, so we get 4x equals negative 3y plus 6.
Subtract 6.
Okay, so 4x minus 6 equals negative 3y.
Divide by negative 3.
Yeah.
Cancels out.
Okay, so y equals what?
4x minus 6 over negative 3.
Correct. You might notice on the answer key, they have, why they wrote it backwards, I have absolutely no idea. That's just goofy. I would accept this also as negative 4x plus 6 over 3. Ever see why? Putting the negative on top or on the bottom, basically if you divide everything by negative 1, you'll get this. I'll accept either one. Either one is totally fine. It's a little like 10 over negative 2 is the same as negative 10 over 2. That's kind of what they're doing here. These are identical. It's just, like here, I would factor out a negative 1. This would be 4x minus 6. And then you can divide the 1, negative 1 1/3 again. Oh, split it up? Yeah. Like here, if you wanted to divide them up evenly, 4x over negative 3 plus negative 6 over negative 3. So y equals negative 4/3 x plus 2 to be fine. Does that make sense? Yeah. Any others? number 13?
We have to go with that, yeah.
Okay, number 13 says, what shape is it? Now, I'm actually going to go easy on you on the, there is a discriminant way to do it, b squared minus 4ac, if you have it in general form, to find out what shape it is. This one, the only time you have to worry about that is if you have an xy term. We do not. Can anybody recognize just by sight what number 13 is? Yeah.
Well, you can look at the square terms, and if they.
So they're both squared. Oh, by the way, if they're both squared, what can it not be?
Eliminates parabola,
It's not a problem.
and then they have differing coefficients.
They have different coefficients, so it cannot be a circle.
And then it's an addition between the two. and
Right.
One's positive, both of them are positive.
Both positive, so it cannot be a
Hyperbola.
hyperbola, so it must be
Ellipse.
an ellipse. Correct. That makes sense. Yeah, let's try number 14. Graph and analyze. How do you get this thing into standard form? First of all, what shape is it in number 14?
It's a circle.
Yeah, how do you know that?
Coefficients are the same, both variables are squared.
Yeah, they're both squared, coefficients are the same, they're both addition. So if it's a circle, let's try this. X squared plus y squared plus 2x plus 4y minus 11 equals 0. This is in standard form, more or less. The secret to success is group the x's, group the y's, and put the number on the other side. So I'm going to put the x's, x squared plus 2x, and then I'm going to leave a blank here, like any complete the square. This is double complete the square. Complete the square always leaves a blank. And then the y squared and plus 4y, that's going to be segregated over here. And I'm going to add 11 to the other side so it doesn't trip over. We don't trip over it. Oh, complete the square, people. What binomial square is this? Okay, good. It's x plus 1. Square the first, double product, square the last. So what should this number have been? 1. Square the last. But if you do that, you have to do it to both sides. Try that same trick here. Can somebody tell me the binomial square of p? Where did this come from? Square the first, double the product, square the last. Y plus what? 2, excellent. What's this? 4, square the last. You can do that as long as you do it to both sides. So what is this answer now? Anybody? 16. That's very, very close to circle form. Circle form needs a minus. So it's x minus negative 1 squared plus y minus negative 2 squared equals, this is r squared. So what's r? 4 squared. So where's the center of the circle? Holly.
Negative 1, negative 2.
Correct, correct. Negative 1, negative 2. And what's the radius? 4. Right. So now you can graph it. Go over to negative 1, negative 2. Then you go up 4, down 4, left 4, right 4. And then draw your best circle that you can, which does not have to be a work of art. So graph and analyze. How many analysis points, quick refresher course, in a circle, how many analysis points? 2. How many in ellipse? 12, not counting eccentricity. What about a hyperbola?
You want us to do that if you put a little list on there?
Actually, no, because they'll ask you about eccentricity at the end of the test. So yeah, if you do, that's great. I might even give you a half point extra credit if you do eccentricity for these. But when you're doing graphing and analyzing, you don't need eccentricity because that's a separate section of the test. If you do, then maybe it's worth an extra credit point. We'll see what happens. What about a hyperbola? How many parts?
14.
14. How about a parabola?
That one, 5.
Close.
6.
6. But you get name them.
Directrix.
Directrix.
Axis
Axis
of
of symmetry. I'll write that down. So directrix, axis of symmetry, vertex. This is kind of an easy part of the formula. Height multiplier.
height multiplier,
Two more things. Focus, and in order to find the focus, you need the focal length, correct? And if you remember on a parabola, see if you can blow up, correct? There's a focal length. Okay. So number 15, that is a hyperbola opening left right, because X is the leader. I think I've got about 3 minutes left, yikes. Okay. Any other ones you want to see broad strokes how to solve? I can at least give you a hint. And you can watch the video at home too. Yeah, 17 and 18 were asking about eccentricity, and 19 asking about eccentricity. How's everybody on number 16? I will give you a hint. Solving systems of equations, you can do it by substitution if it works, elimination if it works, matrices if they're all non-squared. In this one, the only thing that works is substitution. I would get X by itself. Like I got X equals 3y plus 3. I just got X by itself in the bottom equation. Plug that in for X, and then solve. And you should get 2 solutions for X, and then 2 matching solutions for Y. And if anybody wants to see that worked, I can do that on Friday. Number 17, what's the eccentricity of a circle? Amen? 0. How do you find the eccentricity of an ellipse or a hyperbola? It's the same formula.
So you find the focal length that's hot, so C over A.
C over A, correct. Eccentricity is C over A. And what's the eccentricity of a parabola? 1, correct. All right, number 20, is everybody kind of okay on that? You can find a vertical asymptote, you're half done on that. So the front page is okay. We battled our way through number 5. Corn and wheat problem didn't kill anyone. 13, you can pretty much just eyeball it if you know what conditions satisfy what mechanics. Yeah, so oh, okay. Yeah, a parabola has one variable squared, one not squared. So if they're both squared, it would eliminate that. If they're both squared, then you have 3 choices. If they're both the exact same number, like 4x squared, 4y squared, both positive, both identical, that's a circle. If they are different numbers but both positive, like 4x squared plus 9y squared, that one is bigger than the other, so that's an ellipse. And if there's a negative, one negative, one positive, that means it's turned inside out, and that's not perfect. And that brings us up against the wall. So, go ahead and study those off. Gather any questions you have about this for our going through the, remember this is Tuesday, practice exam part 2 tomorrow. We'll go through that on Thursday, and then Friday is for any questions that are left over. So save any questions for today. Well, you come in on your own, of course. But bring them Friday, and go through your notes, go through your tests, see which ones are still sticky. Please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. All right. We'll see y'all later, God willing. God bless y'all at home. Godspeed your healing. Bye.